Next, we're going to talk about functions as equations. Function notation is another way of writing an equation of a function. Function notation would only be appropriate if we're talking about an equation who is already verified as a function. So function notation defines the range, or the y values, of the function by using any value in the domain, or x's. If an equation is a function, then we can substitute y with this new notation f parentheses x parentheses, which we don't actually pronounce it that way. We pronounce it f of x. So the f parentheses x parentheses is really pronounced f of x. So let's say I had an equation y equals 3x plus 1. In function notation, we would simply write f of x equals 3x plus 1. We just take the range, which is the y values, and replace it with this function in terms of x. Writing it in this form is actually a whole lot more descriptive. It tells you what value you're plugging in for x. So to find the value of a function at a given value or expression, that's value or expression, we substitute the value or expression into the equation and evaluate if it's a value, or simplify if it's an expression. So now we will be evaluating. For the next three problems, we're going to use the function f of x equals 2x minus 3. The first problem has f of 5, so we're evaluating the function at the given value 5. Notice that the 5 is in place of the x in f of 5 instead of f of x. So because the 5 is in place of the x, every time I see an x in the function, 2x minus 3, I'm going to leave this open parentheses, and then I'm going to plug in the value 5 anytime that I see an x that should have been there. And then I just evaluate. 2 times 5 is 10. 10 minus 3 is 7. So therefore, f at the given value 5 is equal to 7. All right, let's do this again. The next problem is f of negative 2. Notice we're still using the f function, and so because we're still using the f function says 2x minus 3, but instead of x, because negative 2 is in place of where the x would be, I'm going to take out all of the x's and put open parentheses, and then when I come back, I'm going to fill in with the given value, in this case negative 2. At this point, I just need to evaluate. 2 times negative 2 is negative 4. Negative 4 minus 3 is negative 7. So f of negative 2 is equal to negative 7. On our third problem, we have f of 0. So I still have the function 2x minus 3. I'm always going back to the same f function from before, but in this time, I'm finding the value at the function at 0. So I'm going to plug in 0 every time there was an x in the function. So when I evaluate, I have 2 times 0, which is 0, and 0 minus 3, which is negative 3. Therefore, f of 0 equals negative 3. On the next three problems, I have a new function g. g of x is equal to x squared plus 3x plus 5. And I'm going to evaluate the function at three different values. The first one says g of negative 2. So I'm using this g function this time. Let's use purple. So we have g of negative 2 is equal to, well, x squared plus 3x plus 5 is my original function. Notice every time I had an x, I'm going to leave that x as an open parentheses blank so that I can come in and replace whatever the function value I have. In this case, it's -2. So every time I see an x, I'm going to plug in a -2. So on the first value, I have -2 squared. That's -2 times -2, which is +4. So PEMDAS tells me to do exponents first. Now I'm going to go left to right, do all my multiplication and division. So that's 3 times -2, that's -6. Then I go through and do all my addition left to right. 4 minus 6 is -2, -2 plus 5 is 3. So I have g of -2 is equal to +3. On the next problem, I'm given g of 1. So every time I see an x in the function x squared plus 3x plus 5, I'm going to use an open parentheses for where the x's are so that I can come back and replace all those x's with 1's. So g of 1 is equal to 1 squared plus 3 times 1 plus 5. Now I have to carefully evaluate. 1 squared, I do exponents first for PEMDAS. There's nothing I can do inside the parentheses, so I just do my exponents, which is 1 squared. 1 squared is 1. Then I go back and do all my multiplying, which is 3 times 1, which is just 3. Then I go back and do all my add and subtract. 1 plus 3 is 4, plus 5 is 9. So therefore, g of 1 is equal to 9. On my last problem, I'm finding g of 3. Notice it's still g, so I go back to the g function, which says x squared plus 3 times x plus 5. But instead of x, I leave those open parentheses so that I can come back later and fill them all in with whatever function value that I have. In this case, it's 3. So then I evaluate. 3 squared is 9, my exponents. Then I go left to right and do all of my multiplications or divisions. In this case, I have a 3 times 3, which is 9. Then I go back left to right and do all my add and subtracts. And 9 plus 9 is 18, and 18 plus 5 is 23. Therefore, g of 3 is equal to 23. And that concludes this video.